So while your program is running, it's stored in random access memory. Why do they have the prefix random access? Well, there's also read-only memory, which you can't write to. But random access implies that you can get any piece of it in any order, as opposed to like a tape drive, where you had to start at the beginning and then just keep reading into the end. And if you wanted to position it, to a new place in the tape drive, it was actually a very arduous process. So RAM is very fast, but it's also volatile, meaning that when the computer ends, the computer shuts down, the data in the RAM disappears. So you want to write your data to a non-volatile storage medium. Hard drive, USB drive, flash RAM, CD read-write. We do that with what's known as a file handle. The term doesn't seem to make as much sense to me in terms of Python as it does in many other languages, but if you're a Windows 3 user way back when, or maybe even 95, your computer was very limited in the number of files it could have open at the same time, or the number of graphic objects that it could be drawing on the screen at the same time. It was limited in the number of handles. Handles meaning the way that it represents each piece of data, each thing that it's representing. So this file had a handle, this file had a handle, this file had a handle. And you were drawing this thing on the screen, and this thing on the screen, and this thing on the screen. So if you had all three files open and you had all three windows open, you had 6 handles. And your operating system would crash if you opened more than a certain number of handles. We really don't have that kind of problem anymore, but it's still called a file handle. The way you open it is with the open command, like that. Once you have a file handle, you can write to the file, just like we've been printing to the screen with the write command. Once you are done with the file, you should close it. Let's do that. I'm going to erase all this. Do a save as, because glob is kind of a silly name now that we're no longer dealing with global data. File1.py. Okay. Name, date, file IO, example. I'm just going to give it the very clever name of file. File is equal to open. Let's give it a file name, output.txt, and we're going to open it for writing. Then we're going to print something to it. Write something to it. File.write, once upon a midnight jury, file.write, I ate a raven. There. Edgar Allan's shortest poem. This one didn't make him much money. File.close. So the open command opens the so-called file. The write command sends those bytes that are specified in that string to the file. And then the close command closes the file handle, making the file accessible to the rest of the file operating system. I'm sure you've all seen that error where you tried to do a save as or tried to access something and it said the file was in use. That's because another program had it open and hadn't closed it. In general, what we want to do is we want to close the file as soon as possible. You don't want to write some data to the file and then keep it open. If your computer accidentally gets turned off, then there's no guarantee that that data will be there in the file. You want to get it closed. If the file is still open, you won't be able to copy it into another directory. So if you have some kind of backup program going on, or you're trying to, copy everything out to, a flash drive to take home, if the file was open, it didn't get copied. So we pretty much want to close our files as soon as possible. Not all programs work on that idea. Word, for example, keeps a lock on the file and keeps it open the whole time. But for this kind of stuff, it's appropriate. Open the file, do your business, close it. Well, let's run it, see if it does anything. Doesn't say it did anything. Doesn't say it did anything because I didn't put any print statements in it. All of the action is going into that file. Wouldn't be a bad idea to stick just a print done down here so that we know that it did something. All right, now let's go see if we can actually find that file. Do file open. Tell it that you want to open text files rather than Python files with this little pull down. And then go to your script directory, and there should be output.txt. If we look at it, it may not look exactly like what I wanted. Once upon a midnight dreary, I ate a raven. Okay, I would have at least liked a space there, but my experience with print would have led me to believe that each one would be on their own line. The write statement, unlike the print statement, does not automatically give you a so-called line feed at the end of each line. So if you want to write a line feed, you have to use the /n character, like that. Go ahead and close that output.txt file and then run it again. Now if we go and open that file again, great, it's going to make me move to my script directory each time. That's annoying. Be better off just to go to that folder with Explorer and find output.txt there. You know, if you need to, do view by details, sort by date, and then output.txt is there. Boom, it opened up. Apparently I put a /n in the wrong place. Where'd that period come from? Let's go back and look at the code. Yeah, I did. Okay. So I know that we used hexed.it way back. I'm going to open that file with it. hexed.it. Do open file. Go out to my scripting directory, get it open. And there we see it. It's not letting me zoom in this time. Sometimes it lets me. This is the text. These are the bytes that represent the text. ASCII text, like I think we talked about 12 weeks ago. Once upon a midnight dreary, and then we get to this little space. It's got a 0D and a 0A. 0D stands for character turn, 0A stands for line feed. If we go and hit that ASCII chart, some operating systems like Linux and Mac OS and Unix don't require you to use 0D and 0A as a pair of characters. They just let you use one, a line feed or a character turn. And in fact, Windows supports that now, but a lot of text editors assume that they need to save it in a format where it puts both of them in. If you ever open a file in Notepad and all the text is strung together, rather than being nicely formatted in lines, it's probably because it was created on an operating system that didn't think it needed those two characters. So we have written an ASCII text file by doing that. There are other kinds of data. If you open an MP3 file, you're not going to be able to open it and see all these words and stuff like that because it's got audio data. Same with images, But what does this thing do? It means to open a file for writing. Let's open a file for reading. We're going to put this here before this print done statement. File is equal to open. Let's just open ourselves. Our file name, at least mine, is file1.py. That's our current program. We're going to open this Python script and read its data out. And every language handles the idea of looping to read data in a little bit differently. We're going to go ahead and do the while true mechanism, where we read in a line of data and then we check to see if we're at the end of the file. We didn't read any data. And if we didn't read any data, then we're going to use a break statement to exit the while loop. So let's do this. Line, standing for line of data, is equal to file.read line. And let's print that. I just read, colon, quote, comma, that line of data. And then if the length of the line is equal to 0, it means we didn't really read anything. So we can break. Let's see if that works. Alrighty. Well, it wrote the file, but we don't get any, visible indicator that I opened the file. But then it opened the file for reading, and it printed every line in it out. Does this look odd to you in any way? I just read name, I just read data, I just read file IO example, I just read a blank, I just read a blank, I just read file equals open. Obviously, this is a program we just wrote. Does it look weird, though? Anything bugging you about it? I'm kind of fishing, but do we like all those blank lines? We've never had so many blank lines in our output before. Why are we having them now? Read line is pulling in the entire piece of data, including the /n at the end of the file, at the end of the line. And then print is reading that out. There's a string function which will remove spaces and tabs and /n's at the beginning of data, which is called rstrip. So, excuse me, yeah, rstrip. So line is equal to line.rstrip. Why R? Right. We're stripping off data at the right end. All right, it got off to a good start and then it failed. The reason for that is that we don't want to do this check after we have stripped it of all the spaces and character terms, because if there was no data whatsoever, then this check will trigger and it will break out of the loop. So this should be the next thing that happens immediately after the read line. We need those two lines to go away, and they need to be here instead, right there. If len line, I should have just copied and pasted, you're free to do that, is equal to 0, then break. And there we go. In my opinion, that looks a lot better than what it did the first time we ran it. So what if it tried to open a file that didn't exist? Change your program so that it's not opening a file named file1.py, but something you know that doesn't exist, like pyy. Just change that file name in some way to a file name that you know doesn't exist, and then run it. It blows up. It says, no such file or directory. Now, there's more than one way you could accommodate that, but just be known that if you're trying to open a file for reading and it doesn't exist, then Python's going to let you know about it in a pretty brutal way. It'll crash the program unless you do something to fix that. When you're opening for output, for writing, it erases the file if it exists. And if it doesn't exist, great. You know, it goes ahead and writes a new file. If it does exist, it erases the file and then writes a new file. If you're writing a well-behaved program, you might want to check to see if that file exists. You know, I'm sure you've done that. You've done a file save and it warns you, this file already exists. Do you wish to overwrite it? Yes, no. It'd be nice if our program did that, but it doesn't. This here, the file name, would be better served if we stored it as a variable. And what do I mean by that? You know, that way we could print out error messages regarding it. You know, if I needed to, I could print out, you know, print done writing to file. Well, I don't really want to have to just type in output.txt every single time. It'd be better if I could say writing to file name. So the next time we do this, I'm going to go ahead and delete that. But on the next line of code, the next example we go to, we are going to ask the user for the file name. So let's do that. Our program's going to be a little bit more complicated. We're going to ask the user what they want to do. Do they want to read from a file? Do they want to write to a file? Once we have that information, we're going to decide what the file name is. So, my name, my date, file, IO example 2. While true, let's print a message. 1 to write file, 2 to read file, 3 to quit. Now let's get our input. Choice is equal to input. If I actually had to do math on that choice, I'd go ahead and convert it now to an int. But I don't really have to do math on it, even though they're typing in a number. So I'm just going to do some if statements directly on it. If choice is equal to 3, break, we're done. Elif choice is equal to 1. Let's just put a comment here that we're going to fill in later, or a print statement. Let's write to a file. Elif choice is equal to 2. Print. Let's read from a file. And if all else fails, else colon, print invalid choice. I'm going to run it just to make sure I don't have any blatant syntax errors. Not that I'm expecting it to do anything great. So I'm going to type in something it doesn't expect, like an R. It says invalid choice. Write to file, read to file, quit. Okay. Well, at least it's not crashing at that point. Now that we have our, we're going to put our writing of file code right here. And that elif choice is equal to 1. And we're going to put our reading file here. So let's ask them for the file name. File name is equal to input write to what file? And then file is equal to open. Let's open that file name. File equals open. file name, and we're opening it for writing, so we're going to use a W. Let's write some kind of data to it. I think in this case it's just going to be a for loop or something like that. For x in range 1 to 101, write here's an interesting idea. Can we do this? Is that going to work? Guess we'll find out. For x in range 1 to 101, that will count from 1 up to 100. And then write x, writes that value out, then write a new line, so it'll go to the next line. Once we're done with our for loop, let's close our file and print a message. File.close. And then print done writing to quote, comma, file name. The reason I've been ending my file names with .txt is because Windows will then think of that file as being a text file. I could save to any file. I could call it, Call of Duty.exe or whatever. It wouldn't be a program. It wouldn't be an executable file. If it's got a txt file extension, then when I open, Explorer, I can just double click on it and it will launch Notepad with it. That's the only reason I've been using that extension. Okay, so I'm going to do t.txt. That's the file I'm writing to. And here we go. Write is not defined. I done goofed. What did I do here? Oh, file.write. I messed that one up. Fix this. Still an error, probably because I'm writing that data out. Argument must be a string, not an integer. Okay. We're going to monkey with this line. I'm going to delete both of these print lines, write lines. I'm going to rewrite them just a little bit. File.write, the string version of x, plus a new line. Our print statements always use commas, pretty much. We almost never had to convert anything to a string because the print statement would convert it to a string automatically. But write does not convert things automatically to a string. So just like the int function and the float function, we have a function that will convert a number to a string rather than vice versa. And that's what that is. And then the plus sign just concatenates that onto the end. And of course, there's more than one way to do this. All right, since it's done writing to that file, I'm going to go into Explorer and see if it's there. Go to my scripting directory, t.txt, open it up. I should see 100 numbers. So we got our data there. It wouldn't be a bad idea to move all of this code into a function, but I'm just going to leave that idea alone. All right, let's read from a file. Same idea. We have to ask them for the file name. So file name is equal to input, quote, read from what file. File is equal to open, parentheses, file name, comma, quote R for reading. Now we got to just do the same kind of stuff that we were doing in the other one. But let's pretend that we actually want to do something with those numbers rather than just printing them out. So we're going to have to get that data, turn it into an int, maybe add it to a list, maybe create the sums. I don't know. Let's just get the number and print it out as a number. So while true, in other words, keep looping until we hit a break. Line is equal to file.readLine. Let's see if we got an empty line. If len of line is equal to 0, break. So let's strip that line of data. I'm not going to just call rstrip. That takes spaces out at the end of it. I'm also going to call, the whole version of strip, which takes spaces out from both ends. So line is equal to line.strip. Now let's convert it into a number, like a float. X is equal to float line. That turns that line data into a floating point number, and let's just print it out. Now let's stop indenting, file.close, and let's print done reading from quote, comma, file name. That file should already exist, so I'm not going to write to it again. I'm just going to try to read from it. So I chose to read from file, t.txt, and there's all of our numbers. And we see these dot zeros tacked onto them. They are now floating point numbers, and our program could be doing some kind of math with them, calculating the average, the sum, whatever. So let's add a few comments to this to make this a little bit more comprehensible. Oh, I don't know. I'm almost thinking it's pretty clear. But here, let's put the comment above that FLEN line. Make sure we read any data. And then remove spaces, tabs, and new lines. Goes above that line is equal to line strip. And then that X is equal to float line. Let's say convert to a float. That ought to be enough. I guess we could have put a comment here saying what read line does. Read a line of data from the file. Okay, so the homework assignment based on the idea of files is going to be to take a homework assignment that you've already done, hopefully, and modify it to save to a file. And I'll tell you which one after a bit. I want to go back to the idea of the rainfall array, the rainfall list, the idea of parallel arrays. So I guess before we do that, I'm going to do my walkabout, make sure everybody... So what the rainfall array was, it was supposed to illustrate the idea of parallel arrays. And parallel arrays are when you have more than one, I'm using the word array, an array and a list are the same thing in this language. A parallel array is when you have two lists of the same length where the data is united by its index number. So like you have a name of a person, you have an age of a person, you have their height, and you have their weight. That could be 4 different lists. And then let's put an index number here to indicate which position we're at. Index 0 of the name array might be Joe. Joe might be 10. Joe is 40 inches tall and weighs 40 pounds. Whatever. Index number 1 is Beth. Beth is 20. 65 inches tall. 120 pounds. Like that. So we have more than one list. In this example, we have 4 lists. So we could do this. Name is equal to, and this is not code. You don't have to type it in. Name is equal to, and then that's how we declare lists. You know, Joe, comma, Beth. Age is equal to, 10, comma, 20. Height is equal to 40, comma, 65. And weight is equal to 40, comma, 120. Obviously, it's not very impressive when we only had 2 pieces of data in it. If we had 10 of them, then great. We'd have a whole table of data. If we had 10 students, 10 kids, 10 people, the index numbers would be 0 through 9, and each one of these would have 10 items. You'd have Joe, Beth, John, Fred, George, Sally. You'd have age 10, 20, 15, 9, 18, whatever. Height, 40, 65, 52, 70, whatever. Weight is 40, 120, 100, 200, whatever. So each one of these is related by its index number. On the rainfall program, we had, I believe, just 2 lists. We had a month and we had a rainfall. I'm not going to do all 12 months. Let's do 4 months. So the first month is January. And the program was just asked how many inches of rain was in January. The second month was February. So it's supposed to have a certain number of inches of rain there. And then March, we had some rain. April, we had some rain. Like that. So again, we have lists where the elements in those lists are linked conceptually by the index number. The first item in the month list is January. The first item in the rain list is 12. So these 2 pieces of data correspond. We had 12 inches of rain in January. The second item in the month list is Feb. The second item in the rain list is 0. Those 2 correspond to each other. February had no rain. The third item in that list, March. The third item in the rain list, 5. So March had 5 inches of rain, and so on. So what our program was supposed to do was to ask for values and then do all that kind of stuff like calculating the sum and things like that. Who here did not get the rainfall assignment done? I mean, I'm not calling you out, but do I need to keep talking about this? Feel free to say, yes, I want some more information on it. Okay. So the way these work is if you typically need to know like either a range of values or a range of names or something you're going to step through. So the way our program was set up, our example was days of the week, I think. So we declared a list that looked like this. List days is equal to, Monday, Tuesday, Wednesday, Thursday, Friday. That's enough. And then we had an empty list. Temperature. And we used a loop to go through this list asking for values to add to the temp list. So that we could do that thing where Monday has a certain temperature and Tuesday has a certain temperature and Wednesday has a certain temperature. So we needed a for loop that would go through the days. But we need, so let's do something like that. Let's do, for D in days, print, and I'm going to switch this over to idle. Enter temperature for, comma D. Let me copy and paste this into idle. We need to get that temperature. We know how to do input. T is equal to input. T is equal to float T. Now let's add that to our temperature array. How do we append a value to a temperature list? To any list. We use append. So temp.append T. Once we're done with that, this for loop iterates for every element in the days array. So it's going to go Monday, Tuesday, Wednesday, Thursday, Friday. And then inside the body of the for loop, we ask for the value and we append it to our new list. So by the time we're done, if we just printed those lists, we'd see that we had two lists of the same length. Print days, print the temperatures, day temp. 100, 200, 300, 400, 500. Alrighty, so we can see that we have two lists. The same number of items, same length in both of them. Both of them have 5 items. Numbers 0, 1, 2, 3, and 4. Then if you want to print that out as a nice little table, you can do that. We would just need to have a for loop that would be for in range, the length of the list. So, for I in range, I standing for index, the length, we could use either list. They're the same length. Print the days at position I. Maybe a nice tab to separate the data out. And then the temperature at position I. Let's just see how that looks. Make sure that looks good. By the way, when you're doing these kind of things, whoops, I don't know where /y came from. Conceptually, it's going to work, but your rainfall program wanted 12 months of data. You could just start off asking for 3 months because you're going to get real tired of typing in 12 numbers over and over and over. And once you have it working for 3 months, go ahead and add the rest of the months to the months array, to the months list. Okay, that was supposed to be a /t. Now, how do you find the largest value in an array? There's more than one way to do that. I think when I demonstrated it originally, I actually had a for loop that went and found the largest value in a list. But we know that there are other ways of getting the largest value in a list. What's the easiest way? Yeah, max. We're going to use the max value. So max temperature is equal to the maximum value of the temp. If I was writing this for my own purposes, I'd give that a better name, like temperatures, Then we need to find the position of that value. Or we need to loop through it. And what do I mean by that? Once we find out, here, let me go back to our data. Once we find out that this item, for example, say that was 30, was our highest temperature, we want to be able to print out that the highest temperature occurred on Wednesday. But as two folks pointed out, Doing it the way that we did it in our example on that day only gets you one of them. So like if you have 3 days with a temperature of 100, it would only print out the first one. So the best way to print out the time, the day with the maximum temperature is actually loop through it, checking for it. So let's do that. We'd have to think of a better way to word it, but for I in range, I don't even think I need to do that, but yeah.
We also need another list
to store my days, right? So what I'm going to show them the one way first. So if temperature sub I is equal to our max temperature, I should have used 2 equals, about run out of time. Then print hottest day equals, and then we want to print out that value of the days array, max sub I. This is not a good way to do it because what it's going to do is it's going to say hottest day is Monday and then hottest day is Wednesday, something like that. If you have more than one value with the same value. The format of the output is not going to look great. Inner temperature for Monday, 100, 10, 30, 40, 100, and there we go. So there's our 5 days of the week, and it says hottest day is equal to Monday, hottest day is equal to Friday. That's not a totally cool way to do it. It'd be better to build a list of the hottest days. I'm going to leave it like that, though. Nah. Here's how you would make an array of the hottest days. Hottest days is equal to an empty list. Every time you find a new hottest day, add it to that empty list. Hottest days dot append that day. Something like that. And then we could print them all out at once. If you've got that conceptually, great. I'm going to go ahead and delete that and delete that. You can see that getting the lowest temperature would be very similar, except you would not use max, you would use min. If you want to calculate the average, you do the sum of the temperatures divided by the length of the temperatures. So the homework for files is to modify the rainfall program to write, I should say, the data to file. Ask for the file name, write it all to a file, including the min, the max, and the average, or whatever it was supposed to ask, whatever it was supposed to calculating. So you're just going to take your old rainfall program, and if you haven't finished it, you're going to go ahead and finish it first, upload it to that one, then work on it in here. And as well as display all that stuff to the screen, it also needs to save it to a file. That way you could open up that file in mail and send it to somebody, and you wouldn't have to actually send them the program, or just a cheesy screenshot. So that's the homework assignment based on the idea of files.